Welcome back to geometry. We are at section 10.3, areas of regular polygons. We're going to start off, and they want us to draw two examples of regular polygons. So we're actually going to draw more than just two, but the first one that we're probably most familiar with would be our equilateral triangle. And so we would say that all sides are congruent, all angles are congruent. That would give us a 60-degree angle, 60 degrees, and 60 degrees. Next, we know that we have our square. So a square, all sides and all angles are congruent, and so that would be a regular polygon as well. And we could put in 90 degrees all the way around, 90 degrees, and 90 degrees. We also have a regular pentagon. That would be the next shape in order. And so we'd say that all sides are congruent. And to find the interior angles of a pentagon, we take our formula n minus 2 times 180 degrees. We have 5 sides, so that gives us 540 degrees, which means each interior angle would be 108 degrees, and so all the way around. We also have our regular hexagon, which is over to the right, but let's go ahead and draw in our own. There's our regular hexagon. Again, all sides are congruent, all angles are congruent as well, so we take 6 minus 2 times 180 degrees, which is 720. Divide that by 6, and we know that each interior angle is 120 degrees. Alright, so for each of these shapes, we could also circumscribe a circle all the way around. Okay, and so we would draw this all the way around. We could do it on the square. We could do it on the pentagon. We could do it on a hexagon. And when we do that, our point that's at the center of our circle is also at the center of our polygon. So that's why we have this term right here. This is our center point. If we were to draw a line all the way to an endpoint on a circle here, I could draw one here, I could draw one here, I could draw one there and here as well. These are all going to be called radii, alright? And then the only thing that is new is that this looks like our height, and in a sense it is our height. But because we have this circle drawn, it's now going to be called our apothem. Okay, and so the apothem again is a height, okay, but we're going to call it, or we will just call it A, okay, and A stands for apothem. And so it's a segment from the center that is perpendicular to a side, okay, and so that's this length right here. Then the other thing that we need to know is that on our radius, this would be our segment from the center to an angle, which is what we have. But what we have to know is that it'll always bisect angles in a regular polygon, meaning since we know that we have 120 all the way around, let me change pen colors here. We would then know, since this angle is 120, I mean all of these angles are 120, but they get cut in half by the radius. So this is 60, 60, and we have 60, 60, and 60, and 60, and so on. So we know that all of these triangles inside are equilateral triangles based off of what we have shown. Alright, so a regular polygon is going to be equilateral and equiangular. That's review from a previous unit. If we were to draw in our own hexagon, and actually let's go down here. Before I give you the formula, let's try and figure out why it works. So if we were to draw in our diagonals, we would have one diagonal that would go here, second diagonal goes here, and then our third diagonal goes all the way across. Okay, and again, this meets at the center point. Now, all of these lengths that I've drawn, these are all going to be radii, right? These are all going to be radii. All right, and as I proved up here, in a regular hexagon, these are equilateral triangles. So all of these triangles, again, we have 60, 60, 60 degrees. So all of these triangles are the same. So if I wanted to find the area of this whole shape, right? So the area of my hexagon on this shape would be find the area of one triangle and multiply it by 6 because we have 6 triangles. Okay, so if I do that, I would get 1/2, and then I would use base times height and then multiply it by 6. All right. Next, since all sides are the same, right? All these sides are the same. I could show this with an X or a B or an S, and I'm going to choose S, and S stands for side. Okay, so these are all the same sides. I'm going to have S go all the way around. Well, in finding the area of this triangle, we now have 1/2, and the base of this triangle is now S. Okay, it's not B anymore. Then for the height, we want to draw in our apothem. And so I'm going to draw it down, and here it comes. And it creates a 90-degree angle here and here. Okay, and so the H is now no longer our height. Again, this is our A amount. So this is going to be an A. And then we still have times 6 for 6 triangles. All right, next, I'm going to reorder these. So I'm going to put the A with the 1/2, and I'm going to move the S after the 6. So now I have 1/2 A and then times 6S. All right, if I think about what 6S represents, all right, 6S says 6 times the sides. Well, if our side length was 8 here, and I multiply 8 by 6, I get 48. And what you just found out is you added up all the sides, and so 48 stands for the perimeter. Okay, so 6S is really the perimeter. So I have 1/2 A and then times, and then I'm going to put a big P, which stands for perimeter of our shape of our regular polygon. So this becomes our formula for the area of all regular polygons. We have area is equal to 1/2 lowercase a and then big P, which stands for perimeter. All right, so looking at what I have on this triangle, let's fill some things out. This is an equilateral triangle. We can put 60 degrees, 60 degrees, 60 degrees. We're going to draw in our apothem, which is going to start at the center. All right, we can also draw in each radius. Excuse me, let me put the A here. There we go, 90-degree angles. And then let's draw in each radius. There's one radius, second radius, and a third radius. And so we would know that this is a 30-degree angle, 30 degrees. This is a 30-degree angle. This is a 30-degree angle, which makes this a 30. And then let me change the color. So this is going to be a 60-degree angle. So we have a 30, 60, 90. This is 90. This is also going to be 30, and this is a 60, 30, 90 triangle as well. And our sides, again, will be S for sides, and so this side is going to be S. Okay? And so, again, for our formula, I can take area is equal to 1/2 A and then the perimeter of our triangle. And again, I can take 1/2 our apothem multiplied by the perimeter of our hexagon. Okay, so we have 1/2 A times B. Let's go ahead and jump over to the next slide. All right, in our first shape, we have a square here. So let's mark what we know. We know that the radius drawn is always going to bisect the angle in half. So this is a 45 degrees, and our apothem is always going to create a 90-degree angle here and here. All right. So we're told that the radius is 3 rad 2. That's our hypotenuse. So to move from hypotenuse to leg, we have to divide by rad 2. And so these rad 2's cross out, and A is going to be 3. All right, the other thing that we didn't show you on your notes on that previous page is that this length, which is our apothem, since it's a 90-degree angle here and here, it's going to cut this side in half. So I can, since this is a 45, 45, 90 triangle, I know that this side is also going to be 3. But what I now know is that these two sides are the same. So I'm going to put 2 marks and 2 marks. These two sides are the same. We have 3. And if this whole side length is 6 and we have a square, that means all these other sides are 6 as well. So our side length is 6. Our perimeter is going to be 24. The area is going to be 1/2 times apothem 3 multiplied by 24. And that gives us 36 units squared. Alright, next problem. We have A is going to be 3. Again, this is an equilateral triangle. All sides are congruent. That means all angles are 60 degrees. That means this is a 30-degree angle because the radius will cut this angle in half. It's an angle bisector. So this is a 60-degree angle. So what we can do is we can redraw this triangle. Sorry, let me clean that up. Let's try that again. Alright, so we have a 30, 60, 90 triangle. There's our 90, there's our 60, here's our 30. We know that 3, and so 3 is a short leg because it's opposite our 30-degree angle. So to move to the radius, it gets doubled. That'll be 6. So the radius is 6. And then to move to the long leg, we multiply by rad 3. So we have 3 rad 3 here. Alright, and then since this piece is 3 rad 3, this piece has to be 3 rad 3 as well. And if we add these two up, we get a base of 6 rad 3, or our side is going to be 6 rad 3 all the way around. So side length 6 rad 3. And when we add up 6 rad 3 3 times, or multiply it by 3, we get 18 rad 3. And then the area is going to be 1/2 3 times 18 rad 3, which is going to be 27 rad 3, and that would be units squared. Alright, next problem. First, we have a regular hexagon. That means each interior angle is 120 degrees. And that means this radius, we have 60 degrees and 60 degrees, so this angle is a 30-degree angle. So let's redraw that. We have our 90, we have our 60, we have our 30. We're told that perimeter is 24. So if we divide that by 6, we know that each side length would be 4. So all of these lengths are 4. We know that the apothem will cut this base in half, so let's put 2 and 2. We know that side length 2 is opposite our 30-degree angle. This is a short leg, so that means the long leg is 2 rad 3. That's our apothem, 2 rad 3. And our radius is going to be 2, our short leg, and then doubled, so radius is 4. And so the area is going to be 1/2. A is 2 rad 3, and perimeter is 24, and that would give us 24 rad 3 units squared. Alright, moving up below. This was a typo. You should have an apothem that goes all the way down. Sorry about that. I had a student that just walked in. Alright, so the typo that we have is that you should be told that this length, and you should also be shown 90-degree angles, 90-degree angles here and here, and this should be a 4.1, not 0.1. Okay? So in this problem, note that we don't have, or you're not being asked to find radius, you're not being asked to find apothem, you're not being asked to find side length, perimeter, but what you are being asked is to find the area. So we know it's 1/2 lowercase a and big P, which stands for perimeter. Alright, let's think about this. 4.1, is this an apothem or a radius? Hopefully you know that this is not a radius. This would be the radius, okay? The reason why 4.1 is our A is that it creates a 90-degree angle here and here. So we have area is equal to 1/2, and then 4.1 is our apothem. then our perimeter is going to be easy to find. We just take 7.2 and add it up 5 times, or 7.2 times 5, and that would give us 36. All right, and then you could times this all out and find your area. All right, next problem. Again, you're not asked to find R and A and side length, okay, but we're still going to need these items in order to solve for the area, which is 1/2 lowercase a times p. All right, so just like last problem, we need to define what 23.5 is. And hopefully you said that this is your radius, okay, because it can't be in apothem because you do not see a 90-degree angle here. We have to draw down our apothem. It's perpendicular, 90 degrees. Let's call this A. And if this whole side is 18, that means this piece is going to be 9 and this piece is going to be 9 as well. So to find A, I can go A squared plus 9 squared equals 23.5 squared. And when I find that, I'm going to get A is equal to 21.7. So that's our apothem, 21.7. So 1/2 times 21.7. And then our perimeter, we have 18 times 8. So our perimeter is going to be 144. So if we take all of that and multiply it out, our area should be 1,562.4. And we'll call that inches squared. All right, last problem, number 6. We have an equilateral triangle. So we have 10s all the way around. This is our 10. We know that this is a 60-degree angle, 60-degree angle, 60-degree angle. So when I think of 1/2 a times p, I already know my perimeter. That's going to be 30. So I just need to find my apothem, and then I can find the area of the equilateral triangle. So let's draw in our apothem. It's going to create a 90-degree angle here and here. Let's draw in our radius, and we'll call this R. Here's A. That means this piece is going to be 5, and this piece is going to be 5. I'll put 2 marks. And so we know that, let's change colors again. This is going to be a 30-degree angle. This is going to be a, sorry, that's incorrect. Let me erase that. This angle is not going to be 30. What I meant to say is that this angle here is going to be 30 because the radius will bisect this angle, and this angle is 60. So 5 is a long leg. To move from the long leg to the short leg, we divide by rad 3. Multiply by rad 3 over rad 3. 5 rad 3 over 3 is our apothem, 5 rad 3 over 3. All right, I could find radius, but I don't need it. We're just asked to find the area of our triangle. So we're going to finish this equation. We have area is equal to 1/2. Our apothem is 5 rad 3 over 3 multiplied by 30. All right, and what can we do? Well, we can cross reduce. So 3 and 30 reduces to 1 and 10. And then 2 and 10 reduced to 1 and 5. And so we're left with 25 rad 3 is the area, and we'll call it yards squared. Thanks for joining us. See you next time.